So the people who join later on, they will actually miss it. So next time they will join on time. So if you delay it for 5 minutes and the next time the session starts only after 5 minutes, people won't join, right? And so, but also there are some challenges ongoing right now. I'm very happy that we have some consistent attendance in this program, and I'm very happy that a lot of people are learning, and that's what is our goal, right, Harsha? We as a team in Testoper, we wanted to train and learn from each other. And even if we get few people who have that mentality and we learn together, that's a really good sign. We can't ask the whole 30 million populations to learn together, right? So we got to, those who are interested, we got to work together and learn together.
Okay, then
perfect.
I'll get started.
Sure.
Let me know once you're able to see my screen.
We can see your screen now.
Okay, yeah, thank you. So good morning and good afternoon for people attending from other time zones. Welcome to the 4th week session on masterclass AI with TensorFlow. So far we have been covering the different aspects of machine learning, introduction, different terminologies, artificial intelligence, machine learning, data science, and then we saw types of machine learning algorithms, and then we saw the intuition for those. We spoke about the importance of data pre-processing, how to deal with bias variance, and then we went into some coding part with NumPy and Pandas. So there's one more library which will help you in the data pre-processing phase, analysis phase. That's the Matplotlib. That's the one which is going to help you with plotting the data which you have so that you can get a visual representation and make an analysis. So that is it's a library which we are going to see today. And another thing which we will do is I had introduced you to linear regression. So what we will do is we'll also quickly walk through a simple example in code, like look at how linear regression, how the model is being built. I'm going to use a scikit-learn library. It's very simple, so you can see how the model is being built and how you can feed in values and get the results from the model. So I'll cover that. So we'll start the session today with these. And then after that, we have the big topic, which is which is going to be the last step before we get into TensorFlow, the neural networks. So neural networks is going to be, I had introduced other algorithms, so linear regression, logistic regression. We spoke about unsupervised method in the form of K means clustering. Now what we are going to do is look at come back to supervised method, which is neural networks. I'll introduce you to neural networks and mention like why it is there, because it will become the stepping stone for deep learning, and TensorFlow is a deep learning library. So we will also talk about deep learning, what is the difference between a normal machine learning and deep learning, and just literally 1 minute introduction on TensorFlow and Keras. With that, we'll stop today. So to next class, what we will do is we will look at using TensorFlow. We will build a model in neural network and see how we can solve the problems. And the last session, we'll get into NLP, how we can use TensorFlow for NLP. So that's a plan for the 3 sessions. So with that, I'll get started with the Matplotlib. So I've kept Jupyter Notebook open. I'm not using a Google Colab. I'm using Jupyter Notebook. As I said last time, I'm more of a local guy. So I mean, I like storing the files in my hard disk. So I do that, but there are other means which you can follow too. Okay, so like always, you import the library. Then this is something which is the next line is to ensure that you have the graph that is displayed next to the program when you execute the program, instead of it being you need to output that graph. So you instead of that, if you want to just show the graph as and when you work it out, this is the line which you'll have to use, the inline command, so which has been used. Okay, what I will do is I will create a NumPy array. So just created one with if you look at X, just created from 0 to 5, 11 points between 0 and 5. That is what I have done. So, and I've created a y variable, which is just x squared. for each x you have x squared. So if you look at it, the values are displayed here and you have the square. I'm going to use this for creating the plots, which you can, of course, like this is the simple concept. We will look at when we do the actual problem, if we get to use the plot libraries, which I think we will. I'll show you how it is going to be done with the real data, how the analysis will be done. But to introduce the concept, as always, simple example. So x and y computed. Now what we will do is we will do the plot. We'll use a command plt matplotlib command plot. Look at you can just, it's a simple thing. You can just mark it with x and y inputs, and then this R is for the red color line. This is the color of the graph which you would want it to be. You can have multiple lines or multiple graphs within the same plot, and you can determine the color for those things. We'll look at it later in the notebook. But for this, you start by saying that plot, give the x values, y values, and what you want the color to be. And then you can also give the label for the plot. So that you do by saying plot.x label. Give the label, y label, title. So if you do these things, what it will do is if you run that program, you're going to get the graph. Very simple. This is for a single plot. So you can also create subplots. That is, if you want to compare two values together, like what I have done here is in one graph, I have plotted x versus y. The other graph I've plotted y versus x. If you want to do a comparison like this, then you can create subplot, create one with saying this is what the number of rows and number of columns are there. And then the first one you give it as this is the plot number. That is, you're saying that this is the first one, the first graph which you're going to draw. So amongst this one row, two columns, and the first graph which you're going to draw, give the coordinates. OK, here you notice that not only the color, even the type of line has been mentioned. OK, do the same thing for the subplot 2 and then give the same details. So you will get the graphs next to each other for your comparison. You can also create an empty canvas and then create plots with that. That is also possible. So what you do is that's another way of doing it. So you create the empty canvas saying that this is the figure, and then create the axis for those. OK, so when you're giving the axis, what it means is you're denoting like what is going to be the left bottom, the left side, the bottom, the width, and the height. So that's going to be the it's usually a range 0 to 1. So you set the points which are like this. You basically draw this, and then within that you draw the graph. So using axis.plot. Please note here we had used plot dot matplotlib dot plot. Here we are using the axis which has been created for this empty canvas. Use that, and you can do the same thing to get the graph. This is another way of creating graph. OK, we can also create subplots the same way. Only thing is the plot.subplots gives you a tuple. Tuple is a data type in Python where it's collection information. So it gives multiple outputs. What you do is you get the figure and the axis. So what you can do is create the plots using this way. This is also possible. This is another way of creating the plot. The rest of the portions are the same, so I'm not covering that. So this is just to denote what is going to be the type of this. So we'll go back to how we are creating the subplots. See, when you have the subplots, which is giving you the tuple, what you can also do is you can access it with the array type of notation, like a list type of notation. So you create axis 0, which will denote the first plot, like what we had done here, right? We had mentioned that this is the first one subplot. Like that, in the other method, what we can do is we can have axis of 0, plot the graph, axis of 1, plot the graph. So that can also be done. So now we saw how we could create, the axis with the subplots. We'll get into the next level of details, like how we can vary the size of the graph which we are getting. So if you can define like what the figure size is going to be, accordingly this will change. If you notice, there's a difference between these figures and this figure. So you have the figure size parameter which you can use to define it, and you can also add legends to the graph, like giving indication what it is. So here, if you use the same thing like plot, you have x cube. What it does is it plots it in the same graph. I spoke about doing multiple graphs within the same figure. So it does that here, and you can create a legend here. So when you give the label, what takes is the name for the legend. So when you use the legend command, what happens is you create it here. There are a few other things like where do you want the legend to be. And another thing I wanted to mention was so you can position the legend and see how it will vary. Like for example, some graphs, like you might have the curve here, it might clash with the legend. So depending on where you want the position to be, you can determine that too with the legend command. Okay. So this is creating the figure first, and the axis is created using the subplots command. And then what you do is you create different uh, plots, and this is to show how it can be done with the color coding, how it can be done. You can have the hex coding, or you can give the color name itself. And alpha is a parameter which you can use to determine like what will be the transparency level. So if you want it to be lighter, darker, those things can be worked out. So this is to demonstrate how colors could be given as hex code or the color name itself. Okay, and this is the, I think if I, this is one of the final graphs which I wanted to show. So you can also talk about like how you want, if you have multiple lines like this, how you would want the lines to be differentiated is something which you can do. Like we have like COVID numbers which we are seeing across countries, right? If you want to have different curves for different colors and different ways of marking um, uh, the numbers for different countries, then you can do that. So for the same thing, we create the tuple, we create the figure and the axis, and in the axis we plot. Just for simplicity's sake, I've just taken X, and then the Y value which I've taken is like, just to show you the difference, I've just added 1 and then taken this X plus 1, X plus 2, X plus 3. Those are the things which I have taken. One, you can vary the line width, how wide it's going to be. So if you see that here, you can see the difference in the grading here. The color is the same, but the line width can be varied. You have these things coming in, which will show the difference in the thickness of the line. We can change the line style. Line width can also be shortened to LW. We can have that, and we can have line style, what you want the line style to be. So that can also be done. So here you can see that green, it has been done. And you can also place markers for the values, like for example, X and X plus 9. At that point in the graph, you can place markers. What is the marker you would want? So you can also determine that. So you have the line width, you have the line style and the marker. So you can see that difference here. Okay. And if you can also determine like what should be the marker size and the color. So you have the marker, you have the marker color. You can also mention like what should be uh, the marker border color, what should be inside fill color. Those things can also be done, and you can see the command for this. You can say what should be the thickness of the border with marker edge width, and you have the marker edge color too, which is mentioned, and marker face color, which is going to be the fill color. You can see that it is yellow. So these are different possibilities which you can do with Matplotlib. And any data, like when you have the visual representation, you can come to a lot of conclusions. So Matplotlib is a very useful library for that. You can also determine like what should be the range for the axis. So you set the X limit and Y limit. what you want it to be 0 to 5, or say for here in this case, what we have done is, see, first one you can first graph I have set it as default access range, so the system automatically determines like what should be the access range. But the second plot, what I have done is set the x limit and y limit from, say, access x is from 2 to 5 and y is from 0 to 60. So it shows the graph with the custom access range also. This is also possible in Matplotlib. So you have, I mean, this is just the, I would say, tip of the iceberg. You have a lot of things which you can do with Matplotlib. You have a site which explains that. So I think it is the Matplotlib library site, which you can see. There are different graphs given and what needs to be the code for that. Everything is provided. I'll share it in the chat. You can, after this meeting, you can go through that and know fully about Matplotlib. I'll pause for questions.
Can I ask one question?
Yes.
If you were to go up slightly, and apologies for my ignorance there.
Mhm.
So when you
No
said that
issues.
we start with a blank canvas, what does that mean? Sorry, because I didn't quite catch it.
So you can also, there are two ways of doing it. You can use the plot subplot command directly from Matplotlib, or what you can do is you can create a canvas and then add the figures which you want to add. So you create an empty canvas, add the axis, and then add the plot to that.
So
Many of them use
essentially,
this.
so sorry, you're essentially the subplot that you showed, the one before where you had two graphs side by side. So the graph on the right is basically the uh, the distance between the first observation and the second observation. Is that what we are saying?
No, no, no. This is, I've just flipped it. See, this is X versus Y.
Okay, okay,
And this I've just flipped it just to show you the difference. It's Y versus X. That's it.
okay. All right. Thank you.
This is the inverse of this one. That's it. Any other question? Okay, I'll take that as a no. So what I will do is, so we have so far covered NumPy, Pandas, and Matplotlib. There is another visualization library called Seaborn. I'm not getting into that because that's a bit of statistics heavy. It's mainly for statistical plots. The thing is, like, you need to know the significance of statistics, but I don't know how many of you are familiar with that. That's getting into the data science area, so I will not get into that now. If we have time or if we want to cover that in study circle, I can do that too. So I'll I'll show you a simple linear regression problem, how we are solving it. If you remember, we said that linear regression is to we assume that there is a linear relationship between uh, the input and the output, and we try to find the line of best fit by minimizing the cost function or the sum of uh, squared errors. Sorry, not the sum, the mean squared error. And we try to minimize that and find the line of best fit, which means we find the slope m and c in such a way that for the given data, it gives you the line with the uh, least mean squared error. We get that and then use that line equation to determine the output for newer inputs. That is what we do. So I had covered this as the intuition part, and when we spoke about it, I told you how it does to with a gradient descent mechanism. It changes the value of m and c and then finds out like which value works out fine, so that there is cost function is at a minima. We're going to see this whole thing in code now. Will understand how easy it is going to be. I've taken a simple data as usual, just taken years of experience and then salary, what is possible salary for that years of experience. So this is the data which I've taken. So I'll show you how it is working. So for this, what I'm doing is there are a few libraries we need to import: NumPy, Matplotlib, Pandas, and also like I'll come to scikit-learn too. We need scikit-learn. So there are a few things which we will derive from that. So okay, and then I'll read the data set. So I have the file here. What I'm doing is I'm reading this data set, CSV file. I'm reading this data set and I'm assigning the X values and the Y values. Okay. So if you see here, it's going to be this is what I want it to be X. This is going to be the input, so that like when I give years of input, say here we have 6 and 6.8. Say if I give 6.2, then I will get the salary that is corresponding to 6.2. So this is the input and this is the output. OK, we are marking those. This is how we are doing the we get the data set, read the CSV, create a data set there, and use the index to get the values. So this is for X and Y coordinates here, get those values. And as I mentioned, like I will use the scikit-learn library, which supports machine learning. So use some of the uh, mechanisms which they have given in terms of like how we can split it into test and train data, use that to split it. So if you notice, we don't have to, I'd mentioned that we take around say 60 to 70% as train data and then test data. What I have done here is like using the train test split function. What I have done is I've created the X train, X test, Y train, Y test. So what this function does is once you give the complete data and mention what is going to be the test size. So what it will do is it will create the X train, Y train, X test and Y test. So it does this so that we can use now it has split this data into 66%, 33% train and test split. What we can do is we can train the model with the trained data and check the validity of the model using the test data. Please remember for the test data too, we have the actual output. So using the model, we'll get the predicted output and see how we are how these are comparing. OK. And then what I will do is I'll also import the linear regression from scikit-learn. So create this is the sequence of commands which we need to use for model building. What we will do is call the linear regression function, create an instance that create fit the regressor with the train data. I have given X train, which I had created here, and the Y train, which I had created here. OK, and now I'll go to the prediction part. Now the model is created. I have the regressor which has got the model. So what I will do is I will predict the results. So Y predict, I'll use the regressor dot predict function, pass the test values which I had created here. So here we use the train set to train the model, like find the M and C values in such a way that you can get the line of best fit. Use that to check whether we are getting the right values. For that, we need to see what is going to be the predicted Y value for the test set which we had split here. So we do that here and we'll create the scatter plot for this. So here I have created it with the train test results. So you can see that here it has created the straight line which is there. OK, this is from the test set. This is the plot which has been created. And we have also plotted the X train data there. OK. Sorry, we have plotted the X train and Y train data here in red, and then we have the line which is plotted, the regressor line which we have created. You can see that it has taken a line in such a way that the cost function is low, which is like mean squared error is the lowest. Now we'll do the same thing with the test results. And test results, what we have done is we have also plotted the the X test and the Y test, and using the line we have seen this. You can see that it is pretty close here. And here how you would want to try out something. Say, for example, if you want to see you have 7.1 and 7.9. I have a person with experience 7.5. You want me to find out what is going to be the value, what the model will throw. So you can print the result using the predict command here, regressor.predict, give the value here. You will know what the value is going to be as per this straight line. It's a very simple introduction. Of course, it will not be the real world data will not be this simple because I've taken a convenience data for me to show the explain how we'll code the model. But Of course, you will have in real world data, you'll have to do good amount of data pre-processing. All those things need to be done. You might have to do feature engineering, feature scaling. All those things need to be done before you get to this point. So this is a simple example for linear regression. Any questions on this? I've done this with scikit-learn.
Hi, Harsa. This is Sean.
Yeah.
So what is the accuracy of this model? That's the typical measure we have for any model, right? Like
That is
96% or?
right. There is a command for finding the accuracy. I haven't included that here. I'll share that. I'll include it and share it.
Please, thank you.
Sorry, one more question. After this class, will we have access to this recording?
Yes, you will have.
Thank you.
And you need to be on the Microsoft Teams to get that recording. So you should watch the text message in the chat. There are instructions how you can go up, and there are instructions how you can join. And in the Microsoft collaboration platform, we have a channel called Masterclass. Inside that, we post the presentation and video and everything.
Okay, thank you. I was watching it in the browser, so I'll install Teams. Thank you.
Sure.
Okay. So this is for the coding part. So now we'll move to the theory part of today's session. What I'm going to do is I'm going to introduce you to artificial neural network. What is the intuition? What is the logic behind that? It's mathematically, it's very complex. So I'll not get into the mathematics part. I'll show you what is happening, what is forward propagation, what is backward propagation. At a high level, look at like how it works. And then I'll talk about deep learning and just have a short introduction for TensorFlow. Then with that, we'll stop today's session. Next session, we'll look at how we are going to build a neural network with Keras and TensorFlow. So that is something which we will do. OK. We'll go for the break after we complete the artificial neural network, or if you feel that it's getting a bit heavy in between itself, we'll go for a break. We'll decide depending on how it goes. Okay, artificial neural network. It is a supervised method of machine learning. It is inspired by the neural network in our body. So if you had known if you had read biology, how communication happens in our brain. So it is going to be through neurons, which will be the node, and you will have axons which will connect it to various other neurons. And there is some amount of processing which takes place in each core here, and then it's passed through the axon to the other core, and then the next one does its processing, and that's how the information is transmitted. So artificial neural network is also doing the same. So what it does is there are nodes there are layers where inputs are passed to, and each layer has several nodes, and each node has some amount of processing which it does, and then passes it on to the next layer where the next set of nodes will do the processing, and you determine, like you can see how many layers are required, and then depending on the problem, and then you arrive at the output. So that is what is done in artificial neural networks. It's an old technique actually. It's not a technique which is very new. It is old technique, but it has gained in popularity over the last decade. Some of the main reasons is the need for using deep learning for some of the business problems to be solved, and computation power increase and data increase. Indirectly, like the deep learning, significance of deep learning has led to these things. It is a multi-layered framework. It is not a linear link. Like it's not going to be like you have either y is equal to mx plus c, or you have a sigmoid function, or something which can be logically explained to how it works. Like I explained how intuition is one part, but it's not something like how the clustering is done, what processing is done for neural networks. That is beyond us, but it learns based on the inputs and gives you the output. So it is a non-linear framework which we are looking at. So sorry, this is okay. So you have a method like forward propagation and backward propagation. I'll I'll just introduce you to the term and then I'll mention it when I go to the neural network intuition. What happens is like you have a set of inputs and then you have nodes which will take those inputs in a layer and then do the processing, transfer it to the next layer. It goes on like this till you get the output. In this whole thing, you pass the inputs through various layers and get the output, that is forward propagation. So it starts with random values for this, for the values which are going to be passed, like apart from inputs, like you have a multiplicative factor and a bias factor. So like y is equal to mx plus c, it starts with random values for these weights and bias, and then it does a forward propagation, one pass, sees the output, sees the error, and then what it does is it tries to correct through the backward propagation. So that's how it happens. So it's an extension of gradient descent which is being used. There's a lot of mathematical equations which get into this to understand how neural networks work 100%, but we'll not get into those things. I'll just show you the equation. Explaining that itself will need a lot of time, so I'll not get into that. But this is forward propagation and backward propagation. So why do we need artificial neural network? As I mentioned, like it is for nonlinear computation. It will not all data will have a linear representation, right? Say for example, if you're looking at this data where you have like based on two parameters x1 and x2. So what is going to happen is if the distribution is like this and you want to draw the decision boundary like this. Decision boundary is the way of it's the model's learning to find like how it can split the data, and so that like when you get a new input, it is for a particular x1 and x2. If it is within this decision boundary, you know that it is going to be star. If it's outside this, you know it's going to be plus. So that's a decision boundary. If you have such a thing, it is not possible to express easily in a linear equation. That is first thing. Okay, we can look at having polynomial equations, right? We don't have to have it as y is equal to mx plus c. We can have like y is equal to x squared plus mx plus c, or x cubed or something like that, right? Or if you have like multivariate problems, you can have y is equal to x1 into x2 squared plus x1 cubed into x2 squared. All those complexities can arise, right? For you to reach this decision boundary, it might not be very easy to do this. If you use such complex polynomial equations, what happens is the computation itself is going to be very complex, and like what are the different possibilities with which you check this, that's going to be huge. So you need a non-linear framework. That's the reason you have an option which is going to be artificial neural network. So another example for having a complex relationship is like image detection, right? So you have where they use artificial neural networks for doing this, and you have like car, you have the pixel values from this, like pixel values is going to be RGB which you get, and it's not going to be an easy representation to have it in the other machine learning models. So how this can be passed and then through different layers of neural network for you to identify whether it's car or not is something which you can do easily with not very easily, but which on a comparative scale more easily with a neural network. It is not even possible in other machine learning techniques. So that is the reason you have neural networks. And as I mentioned, it is not something new. It was there in the past, but now it has gained significance due to the usage requirement plus computational power increase and also data. Those are other reasons due to which neural network has become popular. So how does it work? What happens is, so you have, as I mentioned, you have a set of inputs, okay, which you will pass through a layer. Okay, so each input is passed through all the nodes of the layer, and what it does is this layer, depending on how complex you want the problem to be, you might have several layers here. So the output from this layer is passed on to the next layer. And then say in this case, I have taken 2-layered neural network. So you have 2 layers and then you have the final output for the model. That is how this is worked out. So you have these layers which are in between the input and output are called the hidden layers. OK, so this is the flow which takes place. It's not as simple as this. I'll get into details in the next few slides. So you have like you have the input number one, the input parameter one, say x1, x2, x3, and then you have like you add weights to that and you add bias to this layer, and that is what is passed. And another important point is you have something called activation function here. So the activation, after you take the input, add the weights and multiply with weight and then add the bias, passed to this node, activation function works on it, gives the output, and that output is passed to these things. And this happens in each and every node, and it also happens in the next layers. So finally you get the output. So what happens is you set the inputs and set the output, create the neural network with number of layers, number of nodes in each layer. What is the activation function? And what the neural network does is finds the weights and bias that is to be applied so that you have the model ready for predicting what the output will be whenever there is a new input. So that is the logic. It was a long line. I'll repeat that. So what you do is in an what you do in a neural network model building is you have a set of inputs, pass it to some number, pass it to the nodes and the layers. Like you determine like what are going to be the how many layers you're going to have and how many nodes you're going to um, have that, and you determine the output layer. You have the output determined based on this. How it does is it attaches initially. It starts with a random like linear regression where it starts with a random value of M and C, or in the k-means clustering it starts with a random value of seed. Here it starts with random value for the weights and the bias at each layer, and then sees the output. Check, this is the forward propagation, checks like what is the error in the output and does the correction of the weights and the bias by doing backward propagation. There's a differential equation that comes in. We'll not get into that, but at a high level, this is how your neural network works. So this is a more detailed explanation for this. So what happens is that each layer you have the weights for each input, like what goes in, like it's not just the input that is passed on. So you have the weight for each input. I'll explain why that might be required with a real life example. So you have the weights for each input that is passed, and then you have a bias component for that layer. This is repeated for each layer, and you reach the output layer. And for each layer at each node, you have the activation function too. So for the layer, you determine what the activation function is going to be. It can be sigmoid, it can be relu. There are different activation functions which are possible. We'll look at it in the next class. But you have an activation function at each node. So processing is input, weights, bias, activation function in one layer, get the output from this, do the same thing for the next layer, pass it till you reach the output layer. That is what happens with artificial neural networks. So before I go into sort of like an example, like a simple example, any questions about this?
So sorry, can you explain the bias component again, if you don't mind?
So you have y is equal to mx plus c in a linear case, right? This is the
Right.
equivalent of c. The constant which is going to be there, right? So you
Okay.
have not everything can be expressed in terms of multiplicative factor. You need to have an additive factor also. So that is
Okay.
the reason the bias component is added.
And then M becomes the weight of the input.
Yeah.
Okay.
So if you look at it, so what is going to happen is like this. There are three inputs which we are talking about. It's not a linear regression, simple linear regression. It's a multivariate regression I'm talking about here. Sorry, multivariate input. Like you have x1, x2, and x3. So you will have w1, x1 will be passed plus the bias component for this layer itself. Here it's for the layer. So you have that, and then you do the computation based on that. Once I go through the intuition here, I think you will understand a bit more. And it can be used for both the classification and regression techniques, neural networks. So here I've taken a classification technique where the output is binary. You can also have multi-class classification, but here I've taken one as an example.
Okay, thank you.
Okay, before I get into intuition, I think it's the right time to go for a break. And Kader, if I'm not wrong, you wanted to announce something. So we'll go for the break after the announcement. So I'll hand it over. I'll stop sharing and I'll hand it over back to you, Kadir.
Yeah, thanks, Harsha. It's just a minute announcement. So I just wanted to let you all know that we have two new programs starting in May. And the first program is, microservice architecture, right? The build app using microservice architecture. And then the second program is Playwright. It's a test tool for the test automation, right? So these are the two programs that we are starting on May. And you can always look it up in the Eventbrite. And if you are interested, please join them and learn from them. And then the second thing that I wanted to talk to you about is, I know that you're all joining and you're all learning, and I'm very happy about it. But I also would like you to give back, right? And so we are giving back to help you guys, and we also would like you to give back. And if you are interested in, volunteering and joining some of the volunteer teams that we have in Testoper, like programs team, especially right now, we are looking for some solid individuals who can help to organize programs and help us with that, right? So it's actually headed by Harsha, by the way, right? One of the lead on that is Harsha. So if you are interested in supporting us in our programs team or any other teams, right? That wherever you're interested, if you're a marketing person, you can join a marketing team that we have. All our volunteers, everything is run by volunteers. Nobody is full-time employees. So the whole show is run by the volunteers like you, me, Harsha, and every one of us. So the second announcement is, if you are interested, please reach out and tell us in the chat that you would like to join and contribute and support us in this journey. We'll be happy to have you. Right? In addition to getting, also please try to give back. That's what the Testoper is all about. That's the second key thing. And the last one is, we are also looking for some software developers. If you are a software developer, see, we have one program called Testoper Project. Okay. And the idea of that program, this happens every Friday, 6 to 7 p.m. The idea of the project is to really help an individual who does not even know tech, does not even know what entrepreneurship is, what business is, what innovation is. We wanted to take a person like that and help him to become an entrepreneur, tech entrepreneur. That's the goal of that program. It's an ambitious program, but it's without any marketing. We have formed 3 teams, and there are 3 teams who are trying to develop their business knowledge and they're trying to develop their technical knowledge. And recently, Capgemini agreed to support us with new mentors, and there were 3 mentors from Capgemini joined us last week, Friday session. But the message I wanted to give you here is that we are looking for strong technical software development architecture expertise, whoever has an individual to join as a volunteer to help mentoring the teams to develop the right skills and build their products. So if anyone is interested on that, again, please reach out to me and let me know. Those are the 3 key messages. Just a summary. The first one is 2 new programs we are starting. Register it in the Eventbrite. And the second one is, if you wanted to do a volunteer in one of our teams, please send us. And then the third one is more specific to Testoper projects. It would be very kind if you are a software developer or an architect, if you come and join and help the people who is getting started on the tech with your insights, and even join their team and build on that idea, would be really, really appreciated. Those are the 3 key announcements I wanted to make, and I trust you guys are enjoying, and you can go for a break. And Harsha, you can let them know when you wanted to have them to come back.
Yeah, sure. It is 10:48 now, so we'll come back at 10:55.
Yes, thank you. And someone is asking how they can reach out to me. It's pretty straightforward. Testoper@testoper.com. And you can also reach out to me by email. And if you happen to have some of the skills that I have put in the, if you look at my LinkedIn, if you happen to have some of the skills, you can also reach out to me, and I'm interested to talk, right? I'm also hiring as well. All right. So we'll meet back when whatever the Harsha has mentioned, the times. Thank you. Bye-bye.
Okay, shall we get started? Okay, I'll take that as a yes. Okay, before I get into artificial neural network intuition, there was a person who asked about the accuracy of this model, right? So what I did was I didn't know the exact command, so I searched. This is something which we should be familiar with. So you have uh, places where you can look for these things like scikit-learn, which the library which I'm using, they have a scikit-learn.org where you can find various details about those libraries. So what I did was I chose model evaluation there, and there were scoring parameters which were there. OK, so if you notice here, what they have given here is for classification models, what could be the various scoring parameters which can be used. OK, and you have clustering, for which where you can use various parameters, and regression, what is going to be the various parameters which you can use. We're talking about variance, max error, mean absolute error, mean squared error. So what I did was I chose mean squared error. It talks about mean squared error, not root mean squared error. I'll tell you the difference. I'll give you an explanation for that. So you have a way to find the mean squared error for the model. What you do is, in simple terms, what you do is you give the actual output and the predicted output. That should give you the result. So they've also given how it can be used in the code. There are examples. So here, if you see from metrics module, you import the mean squared error, and they've just given an example, the actual value and the predicted value. You take these two things and then just give mean squared error, you will get this value. This is mean squared error. So it might be like the error is actually squared. So if you need to have root mean squared error, then what you need to do is there is another parameter for when you're calling this function, you should set the squared parameter to false. That way it will give you root mean squared error value. So I use that, and this is the value I could get. So what I did was I took mean squared error. I imported the mean squared error and use that, pass the actual value, which is y test, the predicted value from the model, and I set the square to false, which means like I'll get the root mean squared error, and this is the value I got. So I would want you to understand that, see, there are places where we can look for these things, because you need not know everything. Part of machine learning, data sciences, you should also learn how to look at these sites and find the right value and do this. I did it during the break and I could get this. So to the person who asked about accuracy, is your question answered?
So Harsha, one question. So what does that value represent? Like now we got 4,585, right? So
good question. Good question. So what does that, how do you interpret that as a thing? So you should look at it actually depends on what your values are. So if you look at this one, if you look at salary, it starts with say 30 or 1,000 or for close to 40,000, it goes till 122,000, right? So in this range, 4,000 is the mean squared error, root mean squared error, which we are getting. So it can be your what it means is like for the given actual values and the predicted values for each one of those. OK, if you try to find the error, the absolute error, square it, add all those things, add all the squares, take a root of that, find the mean, then take a root of it. This is the error which you will get. It's usually seen as as a metric for measuring regression models. So the value you get, what you can make out of that value will depend on what you're looking at. See, if you're trying to predict the price of a retail item, say, which is like, say, in the range $75 to $100. In that range, if you're going to get a root mean squared error of say $20, it's going to be very high. But if you're trying to predict value of something which is thousands of dollars, and in that, if you're going to get root mean squared value of $20, it means the accuracy is pretty high, right? So
right. So
what you need to make out of that value will depend on what you're trying to predict.
Okay, so in our case, so basically 5,000 means like $5,000 difference of
Yes.
the salary, right?
Yeah, right. So in a range of say 100 and I mean 40,000 to 122,000, it's okay type of thing.
Right.
Okay. Fine. So that I'll move to the intuition part. So now I introduce you to the structure in artificial neural networks. We'll look at a simple example. Okay. So what we will do is we are deciding whether a loan should be given to a person or not. Okay, that is the loan prediction is the output which we are looking at. I'll take a very simple, input output layer to explain this concept. So what happens is whether a loan should be given or not. For simplicity, we'll start with the single input, that is salary of the person is taken into account. And we'll assume that if the salary is above 50,000, we'll give the loan. Else the loan is not given. So this is a classification method, right? So you say whether loan will be given or not given. So it's 1 or 0. So if you represent that as a graph, so what is going to happen is I have a step function. So if the salary is above 50,000, then I'll provide the loan. If it's less than 50,000, I'll not provide the loan. It's a very simple logic. Just use an if condition and you can get this. But we know that in real world, it will not be this simple, right? It's not only salary. It will also be the monthly expenditure for that person, what he has current thing, right? If there is good amount of monthly expenditure, then he'll not be able to pay the EMI. So you have one more parameter which comes in. What is the monthly expenditure for this person? Take both these things into consideration and then work out the loan prediction. Say if the difference between salary and monthly expenditure is beyond a particular threshold, then you give that amount, right? So that threshold, what I have assumed is 50,000. So this is what I'm introducing as a bias in this layer. So what happens is if you look at it, the output from here is 0 or 1. So basically salary minus monthly expenditure. You assume that monthly expenditure is negative. So you're giving the negative value of the monthly expenditure, salary minus, and then you add this one. All these three put together summed up. If it is greater than 0, then you get the loan. Otherwise, you will not get the loan. This is taking it to the next step. So here what I'm saying is when I'm doing greater than 0 comparison, greater than 50,000 comparison, I'm actually doing a step function. So here if you look at it, there is an activation function which is going to be a step function. Okay, so I've indirectly introduced what is an activation function at this node. Okay, so now is this sufficient for determining whether loan is required or not? Maybe we'll have to give higher importance to salary and lesser importance to monthly expenditure. So that's where not a big difference though, but maybe slightly slightly different weightages that need to be given. So what you do is you attach weightage to the individual component. So that is where the weightage comes in W1, W2, and you have the bias which I have introduced here as this one. And what I'm also doing is instead of step function, I'm just shifting it to another function which we are a bit familiar with. We saw it in logistic regression. I'm introducing a sigmoid function here. Okay, we know that for classification techniques we can look at using it. So I'll introduce it as a sigmoid function, which is going to be the activation function here. So in simple terms, what I have done is for the set of inputs, I have attached weights, I've attached a bias, and I've attached an activation function. A very, very simple neural network. I'll pause for questions now. I'll take that as no questions and then I'll proceed to the next one. Of course, it's not going to be this simple. So what is going to happen is your neural network will have several layers and you'll have complex equations which are going to be there, several sets of inputs, weights for all those inputs, and then you'll have several equations which you'll have to work out and find the output. This is I've taken it from Andrew Ng's machine learning course and Coursera. I'll show it in full screen for you to understand. So basically this is the input. It's a single layer neural network which he has taken for explanation sake. So you have x1, x2, x3, three inputs, and then he has assumed 3 nodes for one layer, which he has taken the layer 1. So given passes the inputs through these layers, and then he gets the output. So what he also does is in between there is an activation function where after he does this, he's transforming it to something else and then passing it as an output. The output will be the sum of these things. That's evident here. And you have in this case, he hasn't taken bias. I think it's more for explanation's sake. To give a simple example, he has taken without bias, but usually there'll be a bias component too, which will come in, and it will have like several layers, which is going to be there for you to determine the output. So this is neural network intuition. Okay, so in the first session, I introduced a term called deep learning. We spoke about artificial intelligence, machine learning, deep learning. So I had shown a picture at that point of time. I'll go back to that picture. So to recollect what I had mentioned, you have artificial intelligence, which is going to be giving intelligence to systems to take decisions. It can be a simple if then else condition also. Within that, you make the system learn something based on set of parameters or using a set of inputs, making some sense of inputs. I'm covering both supervised and unsupervised here. So that is going to be machine learning. Within that, you have neural networks, which is one of the methods with which you can do this. And within neural networks is deep learning. So what is deep learning? It's going to be several layers of neural networks with all complexities which are going to come in to solve the complex problems which we are facing. Okay, so that is the deep learning portion. So what is the difference between machine learning and deep learning? Okay, one primary difference, one of the initial differences which we should understand with respect to machine learning and deep learning is that the deep learning algorithms, okay, learn features. What I mean by that is a machine learning algorithm, you need to tell these are the features and then use the technique to identify the relationship between input and output, or if it's unsupervised learning, that makes sense of that. But in a deep learning, it's under neural network, so it's only supervised. So in a deep learning module, what is going to happen is you give a set of inputs. The deep learning algorithm itself will learn the features. To give you a real example, say identification of a cat picture. If you have a set of pictures, you have cat pictures, and then you pass it on to a deep learning network, and your output, your desired output is when you give a new picture, it has to identify whether it's a cat or not. So you train the model with set of cat pictures. So what it does is cat picture will also be expressed in terms of pixels, right? So you will have pixels which you will pass through for each picture. So what it does is based on that data, it tries to find the color variation amongst the pixels. So it tries to find the edges. Say, for example, this is going to be the color variation when the picture is moving from, the background to cat's ear, and from same way from background to cat's leg, cat's eyes. This is going to be the difference. So what it does is it builds these features when in the form of when you are training the data itself, so that when you give a new picture, it checks whether these things are present, and then it gives you the output whether the picture is a cat or not. So the DL models learn features vis-a-vis machine learning models where you need to give the input in the form of features. Any questions about this?
So deep learning,
Yeah,
look at more pattern in data.
yes.
Instead of us training the model from the beginning, feeding it with
Instead of we finding the features and feeding that to the model.
okay, all right. So that's basically what deep learning is. Okay, all right, cool.
Okay. Another thing is typically deep learning performs better with more data, but machine learning models tend to plateau with more data. You don't see improvement in the performance, but with deep learning, it can perform better with more data, and it would also need higher computational powers.
So it's also it tends more to be unsupervised.
No, it is not. Deep learning is supervised.
It's supervised, okay.
Because see, what is happening is it's within neural networks, and neural network is supervised. Deep learning is a subset of neural networks.
Okay.
So examples which we gave, like whether you have hey, this is one point. That's a good question. I'll check that and I'll get back to you on this.
Okay.
Whether we can use this one. I'm not very sure about it. Sorry about that, but I'll check that and get back to you.
That's fine. So I wanted to ask you for a neural network. So the more branches we have, so the more accurate a model would be, right?
Yes.
Okay.
Okay. So and then you need higher computational power for doing deep learning. That's one of the reasons.
Sorry, can I ask a question?
Yeah.
So you said for machine learning, if we give more data, the model will flatten. What does that mean?
So you wouldn't see an improvement in the accuracy of the results.
For example, the salary example which we discussed, is it applicable to that situation or no?
See, that was a very simple example. We can't, that was only for explaining how it works. So you'll have much more complex things, right? So when you have like more data points, you wouldn't see an increase in the prediction accuracy when you're feeding it in, because there's only so much a machine learning model can do.
Okay, so will it bring overfitting situation if we have a lot of training data?
Yes, definitely. If you're going to see, it depends on, it's not overfitting is not just based on training data, right? It is also a representation of the actual data in the training data set, and what parameters you're going to use, how you're going to do that, right? We saw in the bias variance trade-off. So if you're going to, if you build the model in such a way that it's heavily fitted for the training data, then it will be, you would have overfitted it. You wouldn't take care of other scenarios where test data will not show that much accuracy.
Right. So does it mean that its accuracy will decide what parameter we will decide that, okay, this much data is enough to train?
That could be one of the parameters, right? So you will see, you're going to measure the bias and variance, like how much it is, what is the metric you're getting for test data, what is the metric you're going to get for train data. See, in one of the models which I had built, say it was for using random forest mechanism with a boosting technique, and one of the things is the number of estimators which you need to have. In random parameter, it's a parameter which you need to have. And what I did was there is a range for me to determine what is the app value. What I do is I run the program with a range, like say it was in tens, like I started with 20 and then went till 1000, 2000. And then I saw what was the accuracy metric improvement for both test and train data. I could notice improvement, a bit of improvement, not a huge improvement, but a bit of improvement in the train data, but test data it had plateaued. So based on the test data improvement, what I did was I said, like, I want my N estimator to be I think 1720 or something like that. The person who evaluated this result of mine, he asked me this question. It was a graph. I could have shown it to you. I need to search for it, but it was a graph where we could see the accuracy improvement for different estimators value for train data and test data. Both the graphs were there. And as I said, like, I could see the improvement slowly happening till 1720. It was improving. After that, it had plateaued in the train data. So when I said, like, my estimator value is going to be 1720, the person who evaluated it, he asked me this question: did you observe the test data graphs? I said, like, what is with that? So I can see that the improvement is there. So I came to this value. If you notice from 200 itself, you don't see a noticeable improvement in test data. So why do you want to go for 1720, making the computation complex? Okay, if you're doing that, you are actually overfitting the data.
Oh, I see. Because it's probably the curve. If all those points they started lying on the well-defined curve and program follow that curve to predict result, I guess that's what is happening.
Right, could be that. And you see, in case of linear regression, it's a bit difficult to explain because you will definitely have, it's very difficult to fit a line. Okay, I'll give this example. If for your train data,
Right.
if you have the equation in such a way that it is if you have x and y values in such a way that y is equal to x. So what x is equal to 1, y is equal to 1, x is equal to 2, y is equal to 2. If you give that as a train data and you draw a straight line, what is going to happen is you're going to get a straight line with 0 error, right?
Right.
But if your test data is like slightly different, like for x value 1.5, y value is not equal to 1.5, it's 1.75. Then you have issues, right? So it's also important like what you take as train data, what it throws, and when you change the model hyperparameters, are you noticing improvement in both test and train data, or it's only in the train data? So if you take that, go by that, and then you like what I did, I gave high value which was overfitting the model, and I also made the computation very complex. So I could have stayed with a lower value itself.
I just wanted to give Anita input on the question that he was asking. So I know like usually when a model is well trained, or if it has too much data or overfitting, so what would happen is the model wouldn't perform as well as it is, because the model would get used to all the data. So to make prediction, the accuracy won't be the same. It won't be very good accuracy. So when a model is like too well trained, it's not good for the prediction or how the model will perform. So it's best to try to avoid that.
Okay. Thank you. Thanks, Harsha. Thank you, Samir.
Okay.
Harsha, I have one question.
Yes.
So in the program that you showed before, right, we have given the input data, right? And then we have from that input data only, we have, let's say 30%, as test, and let's say 60% as train, correct?
70% as train.
Yeah, so something like that, right? But my question is, can we separate both? Like, for example, can we pass two files, one with train data and separate with test data, rather than splitting the existing data with both?
So we are doing that, right? So what happens is it's just in a single file, but for model training, what it does is if you have 100 values, Nagendra, what it does is it takes the first 70 values to build the model.
Correct, but that is taken automatically by program, right? But I want to control what is the test data. So can I do that from
So
program?
what you're saying is how you would want it to be. Okay, instead of the model choosing it at random, you want to.
Correct.
See, you can do that too. That's not a bad idea, but I mean, scikit-learn allows you to do this with it. It gives you an option to do that. It is a random selection, so that way, in some ways, it's better, right? Instead of you influencing it a bit. In some cases, influencing will help because you want to ensure that the train data too has got representation from all possibilities in the real world. So if you want to do that, yes, you can do that.
Okay.
See the example. Okay, I'll take it as neural network example. Say, I think I mentioned this in one of the previous sessions. So if you're training a cat picture image identity detection module with say all cat pictures which are running, where cat is running, and you give a new picture which is going to be where cat is sitting, the model might not be able to predict it correctly. So what you need to do is when you train, you try to train with all possible values like cat sitting, cat running, cat sleeping, cat running, cat walking, black and white, color, everything, so that the model is trained in the best way possible so that when it gets a new picture, it can do that. Yes, you need to control that.
Okay.
But once you have that complete data set, okay, you know that it is complete representation, you can pass it to the library to do the test train split because it will split it at random. And since your sample itself has got good representation from all possibilities, then you can use that as well. You don't have to intervene there. So basically, when you're saying the data, when you're collecting for the complete thing before you split it into test and train, if you ensure that there is good representation of what is happening in the real world or what is happening in real business, then what you can do is you can use this itself and it will give you good results.
Okay, clear. Thanks, Asra.
Okay. Okay. Another aspect about deep learning is that it is not easily interpretable like say a machine learning model. Say you know that if it is a decision tree, you know that it will say that I'm using these parameters at these nodes to split the data. Or if you're doing a linear regression, then you know that it is going to say, okay, this is the slope value which I've taken, this is the line I've fitted, and this is where the model is. This is the prediction which the model has built. Or if you're doing you can draw decision boundary for many things. In this case too, you can draw, but it's not those individual parameters, since there are several layers and nodes, several nodes at each layer. It is not something which you can easily interpret in terms of the model understanding. So these are the main differences between machine learning and deep learning models. Why did deep learning become popular now? So if you see, there's a huge proliferation of data. So this is something which I took from Forbes. So from 2010 to 2020, if you look at the amount of data created, captured, copied, consumed, everything. So it's grown from 1.2 trillion gigabytes to 59 trillion gigabytes. So which is like 5,000% growth. You can find it. I mean, if you look around, you can find it. There are so many devices around us. Every device is producing data. It's all going to the cloud. There can be a lot of processing which can be done. So the need for getting into deep learning itself was there, because say if you have a good speech recognition module, that's how Alexa came into place. Or I forgot the Google equivalent, or Google Home, right? I don't know I forgot the name, but you have these devices which can take voice commands and then act on it, right? So you have the data, the mechanism with which you can do, and both these things have helped each other to get to newer levels. When you have new types of data coming in, you also find new techniques with which you can make sense of the data to get a new solution. And when you have new solution, like you can also look at like using systems in a different way. So the proliferation of data in the last decade has definitely made deep learning popular. And for doing all these things, you have computational power increase. We know that the famous Intel CEO statement, right? So there's an exponential increase in terms of computational power, right? So it is now we have GPUs which can do tons of work. We have computers which can take in a lot of information and do the process and give you the result very fast. So you have a huge computation increase, and you also have applications that need to use deep learning, right? So like what I mentioned, Alexa, or you want to Facebook. We saw image photo identification or person identification few years back, right? It was correctly identifying. So there are a lot of applications which are getting into this area, and so that is also helping research and deep learning and finding new things, and it's becoming more and more popular. So these are the reasons why deep learning is popular now, and this has also made, of course, deep learning is neural network, and so it has made neural network popular. Neural network was there even from like several decades back, but now it has become popular because of like deep learning's popularity also.
I have a question, just
Yeah.
general. Maybe
Yeah.
you'll be able to help me understand. So if somebody is doing like a voice recognition algorithm, so you'll be basically it would sort of be similar to facial recognition. So the
So
pattern should be the same, right?
need not be, because what happens is for face recognition, what you do is you give it in pixels.
Okay.
But voice, you will have to split the file into something else, some other format, and pass it through the model and try to uh, make sense of it out of it.
Yeah, because I know for voice, I mean, you will still look for patterns in the voice, like certain traits in the
Yeah, that
voice, but I'm not sure what the process look like? It's something I was thinking about
See,
doing.
at a high level, yes, what you're saying is right, the patterns, but I think the inner techniques, they're not the same. I'll also check whether they can use the same method for both these things. I'll check that and get back to you.
Okay, that'll be good. Thank you. I'll look it up then. That'll be helpful. Thank you.
Okay, fine. So with this, I think we have less than 5 minutes. What I will do is I'll just do a 1 minute introduction of the libraries which we are going to use for doing deep learning, TensorFlow and Keras. Okay, so TensorFlow, it provides collection of workflows. This is taken from Google's TensorFlow site. Collection of workflows to develop and train models that can be easily deployed to the cloud, on-prem, or anything. It is not just Python, it also supports other languages. Okay, and mainly JavaScript. And Keras is the API layer designed for TensorFlow, which will not designed for TensorFlow. It's the API layer in the TensorFlow, where you can, the application level layer, where you can invoke some of the APIs and use it for your model building. And there are like TensorFlow is like it's got a structure, right? So there's several layers are there. Keras is at the top there. So what you do is estimator is the other one. So what you do is with Keras, you use APIs to build the model which you would want, do the prediction, all the stuff which you need to do for model building, do that stuff like looking at pre-processing of data, all those things that can be done using TensorFlow libraries. So Keras is the API layer, TensorFlow is the complete library. So we will start looking at building neural network models with TensorFlow and Keras in the next class. So this is a brief introduction, and next class I'll also cover details about more details about TensorFlow and Keras before I start the actual model building. So with that, I've completed the topics for this week's session. If you have any questions, I can answer them.
Thank you, Harsha. Top-notch session, and I actually noticed that Eero Leon. Then I also noticed Samuel. We already talked about it. You both have not logged in through the, and also I know Manda Venkata. You are not logged in through the Testoper account. So just FYI, if you don't, then you won't have access to the channels and the presentations and the videos, right? So if you want to get an access, you can always send us your first name, last name, and your email address. We'll be happy to add them into this account. Top-notch. Top-notch.
Yes.
Remember my 3 points, guys. I told you this May, a couple of sessions we are planning to do. Eventbrite, good place to look at. If you want to volunteer, please reach out to us, even in this chat, or testoper@testoper.com, or even to Harsha, right? Harsha is also one of the great volunteer, works together with me to run the show. And then finally, if you're a developer, we are looking for developers who can provide some mentoring in one of the project, one of the program that we do. Please reach out to us again. We'll be happy to get back to you, and we'll go from there.
Kader, I have a question for you. So you said there was a code. So I gave my email a couple of times. So is there a code that's supposed to be emailed to me when I log in, or not?
Yeah. No. When we add you into the Microsoft Teams, you will get an email from the Testoper Microsoft Teams account. So you need to create your login. Your email is already there. You just have to put a forgot password or whatever, set your password. Then next time when you log in into the Teams, sign out from your existing Teams and log in using the Testoper email address and password that you set it up. Then you would be able to see the collaboration platform.
Okay.
Yeah, it's pretty simple, like any other stuff that we do, right? Only thing, the only thing is that Microsoft does not allow you to keep multiple instance of the team instance, right? You got to log out and log in, and they're working on that feature. Probably they'll have that very soon. All right, so guys, take care. You know that there's another 6 weeks lockdown, so there's a lot of things are going on. So please stay safe. And continue learning and help us also to learn at some point of time. All right.
Sorry, I have one last question for the professor. So when will we have like a project we gonna start working on?
See, after we do the next session, I think I can give you a real world problem. anyways, we'll be looking something close to a real world problem next time, because using TensorFlow and Keras, like there are steps, right? So how we build the layers in neural network and do that.
So the
Or if you
project
want
will
a
be in TensorFlow,
yeah,
neural
yeah,
network.
it will be neural network. What we're going to see
Okay.
next week is going to be
Okay.
neural network. If you want, there are several sources we can look at for data and then look at solving a problem. Kaggle is one of those. So
Okay.
I have given an example for linear regression, scikit-learn, and I've also introduced you to pandas and Matplotlib. So you can look at. I've introduced. I'll underline the term introduced. So if you can work on a bit on pandas and Matplotlib a bit more, then you can look at real world problems. So you will be given a raw data.
Yeah.
You need to do good amount of pre-processing before you get to model level. So for that, pandas will be very helpful. So spend more time on that, and then we can both the visualization and the pre-processing part. So if you can spend time on that, then see the model building as such is not very complex, right? So of course it has its own complexities in terms of hyperparametric tuning, how you adjust those things, but there's good amount of work which needs to be done before that too. Like if you remember the steps. So I don't know whether I can give it as an assignment and
so one thing that we can do, Harsha, on that is, we can try to see, there's 3 teams are formed in the Testoper project. I'll talk to you offline, right? And they are working on some idea, and maybe we can try to see how we can enhance that idea and have that solved using the AI ML. That would be the right approach, which would kind of bring both the teams together in a way that would benefit learning all the parties. Let's talk this offline.
Yeah. So so that was Samuel, right?
Yeah.
Yeah, Samuel. So the thing is, the only reason I'm a bit hesitant is like if you give a real world, with this what I have presented in the class, there is some more homework to be done for you to get to a real world problem. I can provide it. That shouldn't be a problem. You can
Professor,
try. It's your call.
I've done some machine learning. I have a pretty good idea of those. So what I have done is work on real world problem. So that's what I'm trying to do.
Okay.
So building
Then
a portfolio. So maybe I can link up with you sometimes on the
yes,
side.
sure.
You can give me some advice, and I could start
Sure, I
building a
can do that.
portfolio
I can do
that
that.
way. Yeah.
Sure. One source is definitely Kaggle, and what you solve in Kaggle is also recognized in market. Only thing is, see, it's still not a real real world representation, but it will give you the mileage which you're looking at.
That's
If you're
correct.
looking, that is definitely there. So in a project, when you're working in a project, then that itself is that's a different ball game altogether. How you
That's true.
get the information. Kaggle, there's a lot of things which are done, right?
And
But it's an
the
intermediate
data
step.
are heavy too. The data is pretty heavy. It's not 2 lines. It's
Yes,
a
yes,
lot
it
of
is.
data. Yeah.
Yes, it's a lot of. So you can definitely, that's a step which all of us can take. Even I want to, when I get time, I want to solve some of the Kaggle problems for sure. So that's a good step. We can discuss it. We can connect later
Sure.
and we can discuss. Okay.
Absolutely.
And like always, if you have any feedback about the session, if you want me to change something, please drop a note to harsha.testoper@gmail.com. Anything else, if you want to write what you liked, what you didn't like, please feel free to uh, express, and we'll meet again in the
Microsoft
study
Teams.
circle.
Microsoft Teams.
Yeah, Microsoft Teams, and also if you want to send a one-on-one mail to me asking for a few things, I'm ready to help. Let me know. Okay.
Great course.
Okay. Thanks a lot.
Great contents. Yeah, very great.
Kader?
See, I appreciate. Sorry to interrupt, Harsha. I'm very kind to you, but even if it is a one-on-one question, that the same question and answer could be useful for others. So please try to use as much as you guys can use for the teams. That's the best way for all of us. I appreciate you doing it.
Yeah, absolutely. I think we discussed something like that on Mondays. It was a few people in the group, right, Asha?
Yeah. We
started
did
talking
discuss.
about that.
So
Yeah.
you
Any
wanted to say
action that
something,
you
right,
do,
about how you want the approach to be.
Oh yeah. So for the Monday meeting, like it was a few of us that was there. So what we were talking about is like um first we wanted like people, like if they have any question, any concern, they can just post it on team, anybody can help out, either me or either anybody. Like if they know the answer, they could give it to them. And then another part, we wanted to start doing like a group project with everybody where we could divide the task and everybody can come up and discuss the outcome. And so that would help everybody to kind of learn together and get the experience while they're going together. So it's some of the things that we discussed.
Is it a study group or what is that Monday meeting?
Yeah, that was
group.
that with study group. We discussed that, yeah, last time.
Yeah, it's just a program where, you know, we wanted you all to come together, make friends and learn together, right? So that's the thought process of that program. Yeah, good. All good. Samuel, thanks for involvement, man. But one thing that I also want you guys to really do is, you know, join and help the Testoper projects program with all the expertise that you have. You know, it's like coming up with an idea and building a team and learning the business side of it in addition to the technical side of it. And I'm looking for a lot of good developers like you, Samuel, who can come and help the teams. They are looking for help. They need people like you to really help them to build on their idea and help them to learn technical skills and build a product out of that idea and become an entrepreneur. I would really appreciate it. You know, you guys look at the Eventbrite and register for one of the programs and join and see how you can help become a, you know, mentor and a volunteer jointly able to run this program together with me. Okay.
Yeah, I like that entrepreneurship part. So that's something I'll be looking towards.
Please, you can register it and you can join. It's on Friday evening 6 to 7. And I would encourage every one of you who have a programming and development skills to join and you know, help others. Right here you are learning, but you got to use that to help others as well. It should be both ways, and that's the only way our community can grow to its next level. All right, guys. Anything else before we close?
Kader, one question. So if I open an account at testopia.com, then I should get access to material?
No, you have to send your first name, last name, and email address in this chat or in our WhatsApp group, Testoper Masterclass WhatsApp group.
Oh, okay. So I can go ahead and send that right away.
Yeah, and our team will add you in. No issues.
Yeah, okay. Thank you.
Any other questions before we close? All right, Harsha, you can say your dialogue. I'll take that as no and close this.
Yeah. Okay, I'll take that as a no and close this session. Thank you.
Perfect. Top notch. Take care. Bye.
Have a good day, guys.
Bye.
Bye.